Hello Mindsetters, welcome to today's grade 11 maths show. Today we have a special revision lesson on trigonometry. We have selected highlights from lessons shown earlier in the term to help you revise this term's work. So please post your comments and your questions on our Facebook page or on Twitter at LearnExtra so we can help you with your revision. You can also download the show notes for today's lesson from learn.mindset.co.za or click on the link on our Facebook page. Now it's time to get on with today's lesson.
We would like to work out the length of AB. Now, if I look at AB straight away, I position my finger at the angle that's opposite that. This is the side that I need, and I can see that it's facing the 24 degrees. I can also see that the 7 that I'm given is facing the 62 degrees. So because the arrangement of the information is facing each other in an opposite direction, we will use the sine rule. Okay? We can't use the cos rule because we don't have 3 sides and we don't have SAS. So cos rule only SAS or SSS. But the sine rule is when the information is opposite each other. So grade 11's, the sine rule, how does it work? You can always start with what you don't know, and we don't know AB. So we will start with AB. So AB divided by the sine opposite the angle of AB is C, sine C, would equal to AC divided by sine of angle B. So that is the information that I'm given. Notice I on purpose have used AB, what I don't know first, so that what I'm solving for is going to be in the numerator. It's not going to be sitting in the denominator. So now I substitute in the values. So I get AB is equal to AC, I know is 7. I'm dividing it by sine of B, which is sine 62. And then I'm taking that across and I'm multiplying it by sine 24. Right, and I just use my calculator to use those, let's just see, it's here. We've got 7 times sine 24, and we are dividing it by sine of 62. And we get 3,22. So AB is equal to 3,22. Okay. So that was the length of AB using the sine rule. Just see if we've got the other question following up, or if we go right. Now we need to calculate the length of angle Q. Again, if we look at the position of the information, I need to find this angle. Look at whose opposite angle Q. It's this length PR. And look at the given information, side 15, and its opposite 104. So when the information is opposite each other, we can create the sine rule. So we have what I don't know is sine Q. So start off with that. I don't know Q, so I'll start with sine Q. He's found opposite PR, and that will be equal to the other pair of angle side, which is sine P over QR. Now you can substitute, and we've got a very squiggly line, QR. Right, now let's substitute. Sine Q, I don't know what it is, but I do know sine P, that's sine of 104. And I'm dividing that by QR, which is 15. And I'm now going to take PR across and multiply by that, which is multiplied by 8. So I'm going to multiply that by 8. Right, I take my calculator. And we have, let's clear that, 8 times sine of 104. And we're going to divide by 15. And we're going to get 0,51. Now, remember, we're trying to find sine Q. So sine q is equal to 0,51. That doesn't give me the angle, that gives me the ratio for sine q. So if we look at what the angle of that answer is, that gives us 31,16, so 31,2 degrees. So q is equal to 31,2 degrees. Okay, grade 11's very powerful tools for calculating the size of angles. Notice non-right angle triangle, it's an obtuse angle triangle, and the information is facing each other, so we can use the sine rule. So sine rule useful for when the information is directly opposite each other in that diagram. Right, grade 11s, we've looked at the sine rule. We've looked at how it applies, how to use it, which conditions, under which conditions we need to use it, and we now want to look at a case where we would use the cosine rule. Okay, we need to calculate the largest angle in the triangle with all three sides given. So if we have 7, 4, and 9, grade 11s, where would the largest angle be? Where do you think it would be situated? Would it be angle Q? Would it be angle R? Or would it be angle P and Y? Okay, if I go back to what you did in grade 8, you will have remembered that if we have a right angle triangle, where is the largest side positioned? Yes, you've always said it's the hypotenuse. Why is that so? Because this angle here is going to be acute, and this angle here is going to be acute, and both those angles are opposite those two sides, which will be shorter than the hypotenuse because the hypotenuse lies opposite the 90 degree, which is the largest angle in a right angle triangle. So there is this beautiful relationship between the size of the angle and the length of the sides in a triangle. The larger the angle, the larger the side opposite that angle. So we have on this diagram here a side 4, a side 7, a side 9. So we automatically say, hang on, the biggest angle is P. The smallest angle is R because it's opposite the smallest side. So the question's really asking us to find what is P. Now, let's look at the position of P in relation to the diagram. All four sides are equal. SSS is a condition under which we can apply the cosine rule because we've got all three sides. So how does the cosine rule work? In grade 11s at the outset, you're going to have to refer back to your notes, but it's always the side opposite the angle first. So it would be QR squared is equal to the sum of the other two sides squared. So it's PR squared plus PQ squared. A little bit of Pythagoras. But then we take away the product of twice PR times PQ times cos of angle P. Okay? And with that, we then have a substitution that can happen. So we have a 9 squared, we have a 7 squared, we have a 4 squared, and we have a minus 2 times 7 times 4 times the cos of P. And once you've got that, you now need to solve for cos P. So we need to get rid of these terms here. 9 squared minus 7 squared minus 4 squared divided by negative 2 times 7 times 4 is equal to cos of P. Notice that I didn't use the cos P formula because it just means another formula that you have to learn. So it's nice just to always apply the cosine formula and then solve for the one term or the one factor that you need to solve for rather than having a variety of formulae for the cosine rule. So we can now use our calculator. We have 9 squared, which is 81. We're taking away 49. We're taking away 16. And we're dividing that by 7 twos, 14 fours, or 28 twos is negative 56. So we get negative 2/7. And we'd like to know what angle does that give us. 106,6. That's fantastic. So we have cos P was equal to the ratio negative 2/7, and if you look for the angle, P was 106,6 degrees. Great, so we can find an angle. Okay, now we would like to find some areas. How to use the area rule. We would like to find the area of this triangle. It's isosceles. And yes, we are able to find this in a number of ways, but we'd like to use the area rule just to help us out here. This triangle PQR is isosceles, so we know that this length is 6. If it's isosceles, then the angles opposite the equal sides are equal, so that's 48. And we then have that double 48 is 96. So therefore your apex angle is 180 minus 96, which gives us 84. So this angle is 84. We've now created a situation where we have, watch carefully, side, angle, side. With an SAS arrangement, we can use the area rule. How? It will be area of triangle PQR will equal to half of the two sides, so it's 6 times 6, multiplied by the sine of the angle between them. And then we just need to find out what the sine of that is, sine of the answer, and we're going to multiply that by 36 halved is 18. So we're left with 17,9. So the area is 17,9 squared centimeters. Okay. So the important thing with an area is that we want the arrangement side, angle, side. And with the current information, just 6 and 6 and 48, that wouldn't help because my angle wasn't included. It's got to be adjacent. The angle's got to be adjacent to both given sides. Okay, what about the equilateral triangle TRY? Well, what do we know about an equilateral triangle? 11s, what can you tell me are the features of an equilateral triangle? All three sides are equal, equal sides, and all angles are 60 degrees. So let's put that information on the diagram. Each angle is 60, and each side is 4. So is it easy to use the area rule? Yes, because if we look at it, we can take this side, I know is 4, the included angle is 60, and the other side is 4. So the area using SAS would be a half of the two sides multiplied by the included angle. And so we get 16, half of 16 is 8, times sine 60 is 4 root 3, which is 6,9. So the area is 6,9 squared centimeters. So our whole solution process for the area is always to look if I have an arrangement of the side, angle, side, because then I can find the area. If not, I need to go and find those sides before actually applying the formula. What about the following shape, this parallelogram? What is the area of the parallelogram? Well, we have got a formula for the area if we have a perpendicular. So without the perpendicular, we can see very easily that I have two shapes here. I've got this shape, and this one is exactly the same area as that one. So if I can work out the blue and double, I've got the area of the whole shape. What do we know about the properties of a parallelogram? Its opposite sides are equal. So I've got 4 on the side. So if I look at the information, I have side. Let's just undo that. Let's put it in there, right. I've got side, I've got angle, and I've got side. So I can say that the area of triangle ADB is equal to a half of 4 times 5 times the sine of the included angle. And that gives me a half of 4 is 2, 2 5s are 10, 10 times sine 120. So sine 120 times 10 gives me 5 root 3, but that's the blue triangle. So if I times that by 2, I get 10 root 3, which is 17 comma 3. So 5 root 3, which means that the area of the parallelogram is twice 5 root 3, which is 17 comma, what did we say that was? 17 comma 3. And it's in squared centimeters. Right, now I think you've got a good idea of how to use that area rule. We need a side angle side information given, and if we're trying to use the cosine rule, then we need side angle side or side 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 to find that third angle. And then with the sine rule, we just need to have the information that's lying opposite each other. So I would have a side, I would have an angle opposite that. I would have another side, I would have the angle opposite that. I would have another side, I would have the angle opposite that. And if I have that orientation, I'm able to then use the sine rule.
Okay guys, I hope you're enjoying this revision session. If you are struggling and need help, please post on the page or send your questions to the Learn Extra Help Desk. The links are on our Facebook page. But now it's time to take a very quick break. Don't go away, we'll be right back. Welcome back from the break, guys. Doing revision is really important, so I hope you are enjoying this lesson. I'd love to chat to you on our Facebook page or on Twitter, so please let us know how you are doing. Enough of the chat, now it's time to get back to some more revision.
In the diagram, ABCD is a quadrilateral and AC has been drawn. AB is 70, this length is 70 units, BC is 60, AD is 50, and DC is 40. And we've got that angle ABC, this angle over here, is 34. Let's see what we need to calculate. We would like the length of AC. So here we have this triangle over here, where we would like to find out what the length is. So in this pink triangle, what have we got? So far, we have a side, we've got an angle and a side. What rule helps us to find the length opposite that given angle? It is the cos rule. So the formula for the cos rule is that AC squared is equal to the sum of the other two sides squared. So it's AB squared plus BC squared minus twice of AB times BC times the cos of that angle that's opposite the side, so times cos B. Now AB is 70 and BC is 60, and then we have the product of those two sides times the cos of 34. And that's going to give you AC. Now, grade 11s, it would be useful for you to just write what AC squared is using the calculator. So if we fill that information in, we have a 70 squared plus a 60 squared, and we're going to take away 2 times 70 times 60 times the cos of 34. And that is 1536. So write it in as 1536. Don't waste time writing what all those values are. Just do one calculation. And then AC as a follow-up calculation would be the square root of the answer that you've got on your screen, which would be 39,19. 39,19 in the same units that we're working in. And we're working in millimeters, so this would be 39,19 millimeters. Right, so we now have got this as 39,19, and our next question is to find the magnitude of angle D. Now we would like to find what the size of that angle is. Okay, so if we have a new triangle, because angle D is in this triangle ACD, then if we look at the given information, we have 50, we have 40, and we've just been able to calculate this third side. So in terms of the rules, we have 3 sides, and using the cosine rule, the cos rule allows us to find our third angle when we've got the side information. So again, I wouldn't memorize a formula for finding the angle. I would just write down that the angle that is opposite that side, there we go, there's the angle, there's the side. We're now going to write AC squared. So in triangle ACD, AC squared is equal to AD squared plus DC squared minus twice of the product of the sides times the cos of the angle. Now just fill in all the numerical values and then solve for cos, instead of getting cos D as the subject of the formula and then substituting in. So if we substitute in first the values, AC is what we've just found. It's our 39,19. Our AD is 50 and CD is 40. 50 squared plus 40 squared minus twice of 50 times 40, and then this cos D where we're trying to find out what that is. Now we'll solve for cos D. That squared, take 50 squared to the left, take 40 squared to the left, divide by the coefficient, so it's negative 2 times 50 times 40. Let's just make this 50 look like a 50. And then that will all equal to cos D. So now our calculator will be able to help us to just simplify these values. So we have a 39,19 squared. Now, since I have it still on my screen from our previous calculation, I'm going to use all the values. I'm going to use all the decimal values. So that's squared minus 50 squared minus 40 squared. And I don't know why this little plus minus is in here, but it's minus 40 squared. Keep your eye on the screen to make sure that you haven't lost anything. Divided by, and we have this negative 2 times 50 times 40, and that's all equal to a negative 56, which cannot possibly be true. So let's just see where we've made a mistake. It was the 39 minus the 50 squared divided by, let's just see here, because you're subtracting the 50 squared, you're subtracting the 40 squared, and then you're dividing by negative 2 times 50 times 40, and we get equals. Now it's even giving me another answer. So this is very... Okay, let's start again. So we've got that 39.19, which we're squaring. We're then subtracting 50 squared, and we're subtracting 40 squared, and we get that. And then we're going to divide it by negative 100 times 40 is negative 4,000. So we're dividing by negative 4,000. Let's see what we get. That's much better. We're supposed to get a value that's smaller than 1, otherwise there is going to be no angle. So we've now got cos D as 0,64, which gives us an angle. Grade 11s, how do we find an angle if we've got a ratio? There's my shift button of our answer, and we get 50, 1. So our angle D is 50, 1 degrees. So using the cos rule in two situations, finding the length of the side and finding the angle, but utilizing the rule in its formula state and then trying to solve for that angle. So good application of the cos rule. Okay, next question. The sketch below shows one side of the elevation of a house. Some dimensions in meters are indicated on the figure. So our units are in meters. And we have this length, DA, there's a perpendicular. We have BC. We have EF, which is perpendicular at G and F. We have 32 degrees, an inclination. We've got 7.5, and we've got this length is 9.4. And we need to calculate, rounded off to one decimal place, what the length of EC is, which is that length there. And we have to find DCE, which is that angle over there. And then we'd like the area of DEC. So it looks like that would be some kind of a roof or height structure. So oh, and then we would also like to know what the height of EF is. So those four little questions. Let's see if we are able to find out how to calculate the length of EC. Now, I like to go to my diagram and mark the side that I need in relation to what I have. So if I have that length there and that length there, no, I don't actually have that one. So let's just undo here. There we go. So I've got that length. I've got this angle. Let's just fix this with our yellow. There we go. And we would definitely like to find out how long EC is. How would you propose grade 11s? We have 7.5, we've got 32 degrees, and we'd like to find that length over there. Okay. We could work in this triangle EDG and find out what that length is, but then we're still missing an angle over here. So there's a lot of information in that triangle that we don't have. So what are we missing? If we want to find the yellow line in the big triangle is opposite 32. And we've got the 7.5, which is opposite that angle there, but we don't have that angle there. So what would you use, grade 11s, to help finding some information that we may be useful? Okay, we've got to go elsewhere on the picture. And what we haven't used is this line AB. And some of you, I'm sure, are shouting at your screens and saying, why can't we use AB? If we look at AB, AB is the same as DC. We have this perpendicular, and we've got that perpendicular, so these lines are parallel, and therefore they will be equal in length, those pieces, because there's a perpendicular over here, so that will also be a perpendicular. So we therefore have that this pink is 9,4. Now, in this triangle, and I'm going to outline it now in yellow, in the yellow triangle, what have we now got? We've got side, angle, side, and so therefore we can calculate EC by using the cos rule. So EC squared is equal to DE squared plus DC squared minus 2 times DE times DC times the cos of angle D. And we're now going to substitute. EC squared is what we want to find out. So we substitute DE, which is 7.5 squared. We're going to add DC, 9,4 squared. And then we're going to take away the product of the two sides. Okay, and times the cos of angle 32. Okay, so if we take our calculator. Okay, we just need to move down a bit. Just see if it fits. Okay. So we've got 7.5 squared, 7.5 squared. We're going to add 9.4 squared. We're going to take away twice of those two values. Keep your eye on the screen. Is everything okay? Times cos 32. And we get a squared value of 25,0. So that's our squared, which means if we take the square root, we get a 5. So EC is actually equal to 5 units. From all this, we can say EC is equal to 5 meters.
Now it's time for a break, so don't go away. We'll be right back. Welcome back, Mindsetters. Even though we are selecting highlights from previous shows, you can still follow me on Twitter @LearnExtra, or you can post or comment on our Facebook page. Now, let's do some more revision.
Right, grade 11s, let's get back to the house question. We were finding the length of EC. We found that it was 5. Let's carry on and find the next little bits. Let's find where our question is. There we go. Right, we found that, so now we need to find DCE. Who is DCE? There we go. It's this angle over here. We want to find angle C, this one here. And grade 11s, how do you suggest we find angle C? Angle C is opposite 7,5, and we've just found that that's 5 and it's opposite 32. So when information is opposite each other, we can use the ratios in the sine rule. So sine of C divided by 7.5 is the same as 5 divided by the sine of 32. So I've got my ratio the wrong way around. Let's keep the sine in the numerator, otherwise there is no ratio. So sine of 32 divided by the side opposite it, which is 5. So we're going to get sine C. Let the magic machine process all the values. So we have sine 32, and we're going to divide it by 5, and we're going to multiply it by 7,5, and we get a ratio of 0,79. But we need the angle. So to find the angle, we have a magic button. Voila. Let's see what our angle is. There we go, 52,64. That would be our angle, 52,6. So we've got the angle, and we would like to know the area of DEC. How big is that area? What does the area rule say? We've got to have an SAS relationship, so you could use 7.5 times sine 32 times 9,4, or you could use 5, the green angle, and 9,4. I would always, if I have an option, work with the given values because I know those are correct. So if we work with it on the side here, the area of triangle DEC would be a half of 7,5 times 9,4 times the sine of 32. Get your formulae correct. The area rule involves sine and not cos. And let's see what our value is going to be. 0.5 times 7.5 times 9.4 times sine 32. And we get an area of 18,6 squared meters. Let's see if we'd run 7,7. Let's not get it wrong. So that would be 0,7 squared meters, 7 squared meters. Right, and then we have the height, EF. How big is this length here? Okay, well, that's perpendicular. So we really have got a right angle in here. So I'm not going to need any rules because that's opposite, that's the hypotenuse. So I really have the sine of 32. So if I use the length, in fact it's EF that we need. We need this length over here, and we know that that's 3.5. So we really only need this portion here, EG, which is opposite 32. So sine 32 is equal to EG sine 32 is equal to EG divided by 7.5. So our magic machine is able to do these amazing trig ratios for us. Sine 32 multiplied by 7.5 gives us 3,97. So EG is 3,97, which added to 3.5 will give us this final value of EF, plus 3.5 gives us 7,47. So 7,5. So EF is 7,5 meters. Okay, so that was the plan of a house that we could use some trigonometry on. Let's see another possible question. Okay, this is a photograph of an Airbus A380, and it is the largest passenger airplane in the world, and let's see how we can use trig. In the diagram below, the top view of the plane is shown, and the wingspan of the plane is 79,8 meters as shown by the line DE. So from tip of wing to the other tip is 79,8. And if it's given that the length from the wing to the middle of the plane, dr, from the middle of the plane to the tip of the wing is 43,4 meters, and DE, we've already got that. Determine, round it off to one decimal place, the size of angle DRE. So we can actually take the model, the real model, and we can create lines and angles to show what that model looks like mathematically. And so we would like to find out what is this angle, what is the size of that angle. And grade 11s, what would you say? You've got side, side, side. If I have three sides, how do I calculate an angle? Which rule helps me to find an angle when I have three sides? Yes, it's the cos rule. So this would be the side that's opposite the angle. That's how we start the formulae. So it's 79,8 squared. We're then going to equate it to the other two sides squared. So it's 43,4 squared plus 43,4 squared. We're then going to take away the product of 43,4 times 43,4, and we're going to multiply it by the cos of angle R. We then are going to solve for cos R by taking away these values and dividing by that. Let's hope that our calculator this time behaves, because the last time it did some strange things. And obviously it's not my fault, hey? It's all the calculator's fault. All right, so 79.8, we're going to square that. We're then going to take away 43.4 squared. We're going to take it away again, minus 43.4 squared. Let's just go back here. There we go, delete, delete. Let's go one more and let's delete that. Right, 43.4 squared. And we're then going to divide. Aha, I know why I did this the wrong way around the last time. Because grade 11s, remember, I want my numerator. And if I want my numerator, I need to have a bracket for that answer. And this is when you wish that the calculator had a button that said end. Otherwise, we'll just keep going all the time. Right, divided by -2, and we're multiplying it by 43.4, and we could have squared it because it's two of those factors. And we can then say, right, what's the ratio for that? There we go. So we now have a ratio of negative 0,69. Okay, before we proceed, grade 11s, if my cos ratio is negative, what indication do you get to the size of the angle that angle R is if it's negative? Can you tell me? If the cos ratio is negative, it implies that angle R is obtuse. So I'm expecting angle R to be obtuse. If it's not, something is wrong and I need to go and find out what it is. So magic button for the angle equals 133,7. So there is that angle that's sitting there between the two wings. And then what is the area of DRE? What is that area there? What rule involves area? It would be half of side angle side. So it would be 43,4 side, side, and then the included angle is the sine of the angle we've just found, which is 133,7. So that area would now be, as you can see, we cannot do trig without our machine. We now have the sine of the answer, and we're going to multiply it by, or divide it by 2. We're going to multiply it by 43.4 squared, and that gives us 681,3. 681,3 squared meters. And we've got a very simple situation where we were able to just in 2D demarcate the wingspan of the plane and the length of the wings in terms of finding the angles and the area as well. So it really is a 2D problem. The challenge question that you're all busy with at the moment has got a vertical plane and it's got an oblique plane as well to work in. But let's proceed with our next question. Okay, the angle of elevation, let's just see here. In the diagram below, a tree is situated on the opposite side of a river, R and T. So here's RT on the bank of the river, and the tree's on the opposite side. Lovely tree, I like it. The angle of elevation of S, the top of the tree from T, is 49 degrees, and E is a point vertically below S, and in the same horizontal plane as R and T. RT is 12 meters, RT is 46, and ERT is 39. Now, grade 11s, don't switch off to when you have a whole kind of a comprehension. If you have a comprehension, read it once just to get the context. So I've now got the context. There's a river, there's a tree on the opposite bank, and they've given us some angles and some measurements. Read it again to extract what those measurements are, to make sure that you've got every measurement on the diagram. And then you need to read it again to make sure you haven't missed anything. Because when you first get thrown with a problem, it's difficult to digest all the important facts at the outset. So be patient, read it once, read it twice to extract all the measurements, and read it the third time to make sure you haven't missed anything. So let's go to it. So we've got the context. We now want to see the values. The angle of elevation of S. So somebody is standing at T. They're looking up at S. And when they look up, that's the line of sight. It makes 49 degrees with a horizontal. And the horizontal would just be this line that's directly opposite to the base of the tree. E is a point that's vertically below. Why do they say this? Do you think that this is just here just for fun? Vertically below. Anything in mathematics that's in a vertical relationship means that you are at right angles to the horizontal. So there's my little right angle to indicate that I've got a perpendicular. And in the same horizontal plane as RTE. So these are forming a horizontal plane, these 3 points. So there's my horizontal plane. I like to color it in because whenever you get 3D diagrams, it's very difficult to be able to draw it. You're trying to, on a 2D shape, draw what should be in perspective in 3D. And for those of you like me who are not very arty in drawing these perspectives, it's quite difficult. So what I try and do is color in the horizontal plane just for emphasis that that's my horizontal and my vertical is standing up there. We then have RT is 12 meters. There's RT, it's 12 meters. And RTE is 46 degrees. RTE, that angle on the ground, is 46, and ERT is 39. ERT is 39. So these lines that have been drawn from the foot of the tree to the opposite bank, from the foot of the tree to the opposite bank, these lines are making those angles on the horizontal. Okay, let's see what we need to focus on. Determine ES, the height of the tree, rounded off to 1 decimal place. So ES, that height of the tree, is it possible for us to find that length? Well, if we, in the white triangle, we're probably going to say there isn't enough information. We have how much? How much info do we have? We have one angle. We've got 49 degrees. So it's obvious that I need to go and find something else before I go and find ES. In this white triangle, I need to find ES. I only have 49 degrees. I am short of information. So I need to go and extract that extra information from somewhere else. And the only other place I can go is this yellow triangle, the horizontal plane, because it shares ET as a length. So if I can find ET, then I'm good, because I then have a length and an angle in a right angle triangle, and then I can find ES. So our job needs to take a step back. We need to go and find ET, and we have ET is opposite 39, and the 12 is opposite E. So now we still have some missing information. There's E. Could you find angle E? Is it possible to find angle E? And you're all shouting at the screen because you're saying, yes, I can see it, I can see it. It's an angle sum in triangle. They're the other two angles, so that's great. So let's find angle E. Angle E would be 180, take away the 39 and the 46. And the reason is angle sum in triangle. And if we do our little sum, okay, we don't want to pop round, so let's just go there. We have 180 minus 39 minus 46, and we get 95. So angle E is 95. Now, where were we going with this information? Because 12 is opposite 95, and the one that we want is opposite 39. So we're going to start off with ET, because that's what we don't know. So ET divided by sine of 39 is equal to 12 divided by sine of 95. And get into the habit, grade 11s, of actually filling in. This is 95, so let's fill it in. As we calculate it, we fill it in. So ET is equal to, let's see if it will move now. Okay, we're a bit, there we go. So we have a 12, and we're going to divide it by sine 95. And we're then going to multiply it by sine of 39. And we get what? We get a 7,6 if we round off to 1 decimal place. So we've got a 7,6 meters. That is the distance between the foot of the tower and person T that's on the other bank. Okay. And then determine the width of the river rounded to 1 decimal place. Assume that RET are points on the banks of the river and that the width is constant. So the width of the river, let's go and see where the width of the river is. So now, we haven't finished the question yet because we found ET. This was that length ET that we were searching for that was common to both triangles. But we're now going to find how long ES. That was the first question, so we kind of just, well, I just abruptly stopped there. So let's keep going. In triangle SET, we have this length is what we want to know. It's opposite 49, and this distance is adjacent. So the cos of 49 is equal to adjacent, which is the side we've just found, which is 7,6, divided by, no, it's not cos 49, it would be tan. because this is adjacent and that side is opposite. So what joins adjacent and opposite? It's our tan ratio. So we have the tan of 49 is SE over ET. Therefore, SE would be ET, which we've just found, times the tan of 49. So we have, no, we want to delete, there we go, clear. Tan 49, and we're going to multiply it by 7.6 to give us 8,74, and that would be meters, that would be the height of the tree. That's how tall that tree is.
Thanks for joining me and for chatting to me during the show. Please visit our website learn.mindset.co.za to get the notes and to watch the videos from earlier in the year. And remember, we are here to get you through the year, so stay connected. Goodbye.